Welcome back to Data Math Concepts. Today, what we want to look at is the idea of bearing. What is a bearing? A measure. We're talking about a measure of turning. And this measure of turning is always from the north and it's always clockwise. So we wanna make sure that we understand that a bearing is a measure of turning from the north in a clockwise direction. Well, the fact that we mention north would suggest that we need to identify where is north. So basically, you could just easily put up to like a cross, and we have north, south, we have east, and we have west. We need to understand these cardinal points as we try to navigate. A clockwise direction refers to the movement like the hand of a clock. Like the hand of a clock, it goes in that direction. Hand of a clock, 12, 1, 2, 3, 4, 5, 6, and it goes on and on that rotation. So understanding that it's a clockwise rotation from the north line, let us look on this, the north. The north line has two numbers that normally works with it. Also, I want to make note that all bearings are given using 3 digits. So 0, 0, 0 refers to 0 degree. Now, because the north line is vertical and the east-west line is horizontal, where they meet, we'll end up having a set of right angles. So we have 4 pairs of right angles, 4 sets of right angles, should say. So here we'll definitely have, very good. All right, so here would have a 0, 9, 0 degrees, which refers to 90 degrees, which means that from this north line here, coming to here, that's a 90-degree angle. But we would have noticed that because of the fact that we have a vertical and an horizontal line meet. So it means then if I'm traveling east, I'm going on a path of 90 degrees. From north to south, as you could see, let's change the marker. We're talking about a straight angle, which is gonna be 180 degrees. If we're moving from north all the way to west, well, we're going along a 270 degrees, as you could see there. And then if we go along from north and then head all the way back to north, we're covering 360 degrees because we would have made a perfect circle. So going from north back to north, we'll end up with 360 degrees because we're making a perfect circle. Now, understanding that everything is from the north, and as we try to navigate and move along, what we want to do is to try to see where the bearing that we intend to find is located. What do I mean? All right, let's look on this. Let us say A is on a bearing of, say, 70 degrees from B. We want to make sure that we understand that you can't move on a bearing without a reference point, where you're coming from. So from B is extremely important. It means that this point is B. Normally, I just write my B somewhere near that. So that is B. We're referring to this point. The bearing is on a path of 70 degrees, but remember that this is where we have 0 degrees, and this is where we have 90 degrees, which means then 70 degrees is between the 0 to 90. You don't need to measure this with a protractor. The idea is that trigonometry will work itself out. We need to make sure that we go off in that direction. So 70 degrees is anywhere going that way. Now, we don't have to try to make it be 70. If it is in the right quarter, in that right quadrant, we're good. Let's mark the angle. In marking this angle, all bearings are from the north. So we're not going to stay at the point B, like we're not going to try to mark the bearing from right here. We can't. Bearings are from the north. This is the point B. We step above it to here, and then we mark in a clockwise direction until it touches a line that leads to A. So A is right here. This degree is our 70 degrees. So the bearing of A from the point B is 70 degrees. Let's look on another one. Let us say we intend to look at this. So we are suggesting that T is on a bearing of 200 degrees from M. And we could add some things to it like some 100 kilometers away. Now, what we want to do with this statement is to read to see what's going on. It says T is on a bearing of 200 from M. This is very important. From M, which means that when I do drop my, I call this my cross to navigate, my north line. The north line is very important. In addition to the north line, we could put on stuff like south, east, and west if you don't remember, but the north is of great importance in navigation. Now remember that T is on a bearing of 200 degrees from M. It simply means that we want to classify this point as M. That's the point M. Please do not try to mark the bearing from the point M because all bearings are from the north, which means that I need to understand where is 200 degrees first. We'd have our 0 degrees there, our 90 degree here, 180 here, and 270 there. It is suggesting that the bearing 200 degrees is somewhere in this quarter, which means I need to move in that direction. From my point here, now understand that the T would be somewhere here. You stop this, you can call that T. In order to mark the bearing though, the bearing cannot be from here. All bearings are from the north. So I'm going to step to the north of M, that's there, and I'm going to go in a clockwise direction in a circular path until it touches the line that leads to T. This degrees is my 200 degrees. Hence, the bearing of T from M is 200 degrees. And I could now put on my 100 kilometers because it is 100 kilometers away. Basically, this is just a quick foundational principle as it relates to bearing. Thank you for watching. Please like, subscribe, and drop a comment. See you next time.